Hello, lovely people. Hopefully you can see and hear me. And you've been having a lovely week so far, even though it's only Tuesday. How is everyone? I can see some familiar names, James and Aisha and Fazmina. I believe you've been here before. And Ward, hello. Hello, everyone. Hello, AFT. Yes, lots and lots of familiar faces. Hello, Lee. As usual, I'm going to give it maybe a minute for some other people to show up. Hello, Igya. Hello, Kushi. Or Heko from Kushi. It's a different one, but it's still a greeting. So I shall say hello as well. Hello, Fatima. How is everybody? What will I be covering? I will get to that, but this is going to be sort of like mole calculations type things and some ideal gas. If you ever, hi, Night Hardcore. Good. Glad to see you're not jumping the gun. Although jumping the gun is not a bad thing. Sorry, as I was saying, Aisha, if you go in the description, it does give sort of like the overview of what we're covering anyway, but I will get on to that. That's a cool hairstyle. Why, thank you. It is the one that pops out of the shower. Yes. Hello, me. Oh, that sounds weird saying hello, me. I'm glad that I can help you with this topic, Charlie. I'm fine, James. I've been a little bit under the weather, but I'm happy to see you guys here. Hi, Aisha. I do this, so we have space in the office to do it, and we have space at my home to do it. Okay, I'm going to get started. I'm going to share the presentation with you because it's been a little while. So, all right. So we're doing calculating reacting masses. So I introduce myself every time, but I will say hello to all the new folk. I'm Georgia, head of chemistry at SnapRevise. I have a master's in kind of chemistry. It was kind of like split up between chemistry and a bit of neuroscience. And then I also have been teaching for like the last 6 years or so, teaching and tutoring. So hopefully, yes, I say this every time, hopefully I can help you with the topic. I should start saying, I will help you with this topic. Sounds better, doesn't it? All right, so what are the web classes? They're a recap. So we're not going over every single thing you need to know. We're going over key points and sort of key concepts, and we're practicing sort of the main skills, but it's not everything under this topic, especially as some of the topics are split up as well. We're going to be doing some exam questions and how to sort of think about them, and then you have time at the end to ask me questions. And this is part of sort of like a free tester for what is going to be part of our ultimate package on October 16th for our launch of SnapRevise 2.0, which I will tell you more about at the end. Cool. So as usual, somebody will get a free account with us. If you follow us on Insta and then share a picture of the web class, so screenshot it and tag us in it, then you may win a free account. Hurrah! We all love free stuff. And everybody gets a coupon code at the end. So that's sort of us keeping you here. Yes, apart from the teaching, the amazing teaching should also keep you here, but also coupons, because who doesn't like a discount? Right, so objectives. So this is, Aisha, this is where your question from earlier comes in. So we're going to be doing calculations with moles, concentration and volume. So that's all of the reactions, making calculations with moles rather than just sort of like the molar masses kind of things. We're going to be looking at what the ideal gas equation is. We're going to be looking at the room temperature and pressure approximation for calculations. So we're not going to be doing any ideal gas calculations that aren't at room temperature or pressure, as that is only on one exam board. Oh, Mesmoria. I'm so glad that you are here, even though you're not doing chemistry. Yes, it does include quite a bit of chemistry. I do wish that the biology syllabus would explain some of the chemistry so that students, aren't so lost, but I did not come up with the syllabus, unfortunately. Okay, so I'm gonna, as usual, so we cover AQA, EdXL, and OCR. So I give like a short amount of time for you to just check what specification points that we're running through. As I say every time, you should be using them as a checklist and making sure you know everything, because that's up to you to make sure you know everything by the end of the year. So yes, I don't stay on these slides for very long, just have a look. Quick look. Yes, it's supposed to be somewhere between like an hour and 15. Often they overrun. I'm going to try my best not to overrun this time. So fingers crossed, everyone. Right. Oh, cool. So the first thing we're going to do is look at the things we should already know from either GCSE or from sort of earlier on in the year. I know we haven't had much of the year, but hopefully you've learned some things since September. So someone tell me that a sort of like perfect definition of a mole, not the really short sentence one, the one that actually explains what a mole is. What's a mole, people? Nobody knows? I'm just sort of sipping my tea. Smallest substance there is, says not quite right. Maliha, is that right? Maliha. Ward says the amount of substance that contains the same number of particles, the atoms of 12 grams of carbon-12. Casey says 6.02 times 10 to the 23. Malia. Oh, Malia. Okay, that makes perfect sense. Malia. Hello, Malia. Thank you for the pronunciation guide. Yes, so we're kind of there, but I'm going to combine some of your definitions. So the sort of standard definition that you get when you Google, Vidit has kind of said it. Yes. Oh, Hasnain. Hasnain. I would appreciate also a pronunciation guide to your name, because I don't quite know how to say that. Hasnain. Yes. So you're right. So the first thing that you usually get when you Google a mole is it just says an amount of substance, which is not that helpful, right? Because how much substance? So the amount of substance that a mole is Avogadro's number amount of substance. So this is just a standard number that tells that that Avogadro came up with for carbon-12, which we went over a bit more last time. Hello, Nick. So Avogadro's number is, somebody's already told me, so that was Libby. Hello, Libby Flaherty, that is perfect. Apart from your power, it should not be to the power of 27. It should be 6 oops, that's a cross, not a point, 0.022 times 10 to the 23 particles. So if we have any element or any molecule, if you've got 6.02 times 10 to the 23 of them, so that's like 6 with 23 zeros, that's a mole of that substance. Is everybody, you are late, sir. Hi, sir. Hello, sir. So many hello, sirs. Yes, you are late, sir. You should try to be on time for your web class. Set a reminder. It helps. Cool. So mole is Avogadro's number amount of substance. We're going to really quickly recap how you swap between dm cubed and cm cubed, and per dm cubed and per cm cubed, because it's a little bit different. So help me out, guys. How many centimeters cubed are in a decimeter cubed? Pradeep, I don't know. I don't know who will win the Nobel Prize. 1,000, yes, perfect. Cool. So then tell me, so many perfect answers. Yes, it is 1,000. So tell me how many so remember that to the power of -3 means, means 1 over dm cubed. So tell me how many dm cubed to the -3 is cm cubed to the -3? Help me out. So if we've got 1 dm cubed, how much? Yeah, Deca, you're right. Yeah, perfect. Yes, Casey. So we've got it in both ways. So we can either write it 0.001 or we can write it 1/1000. So thank you. Oops. Yeah, I've got too many. There we go. Cool. So last one. How many dm cubed are there in a liter? Hey, code second, don't judge. You don't know that. They might have just been typing phrases or like they just got it. Even if you are copying, I would rather you get involved so you can copy. 1, yes. Casey says too many. I wonder if you're referring to too many liters or too many people. Yes, it's 1 liter. Oh, thank you, Ms. Moria. But you know, if you want to compliment me on my brain. It's the better part of me. Cool. So, wicked. What is molar mass? Help me out, people. That's another definition we need to know. Molar mass, I'll give you a clue. It's represented by M, big M, not little m. Little m is just mass. What is molar mass? So that's molecular mass, Ward, rather than molar mass. Yeah, Shalyn, Night Hardcore. Yeah, we're all kind of, molar mass is the mass over, yeah, so we've got quite a few different definitions. So we've got some sort of formula definitions, as in like, how would you work out molar mass? We've got Kula saying mass per mole, which is kind of what, and then Malia, remembered how to pronounce it in the last second. Malia saying the total molecular mass in a molecule. Yes, so we're kind of like, we're kind of close. The definition I'm going for is the mass of 1 mole of substance. So that substance could be an element, it could be a molecule, so it doesn't really matter, but it's 1 mole of it. Yeah, so mass of substance per mole is good for Pradeep. Abigail, yeah, perfect. Night Hardcore has got the correct thingy units. Yeah, perfect. Okay, so this is kind of like, this covers ish all of the things that we need to know before we move on. So I'm going to go ahead and start on calculating moles, concentrations, and volume. Okay, so in a solution is the sort of main place that we're going to be calculating concentration and volume, because of course concentration refers to aqueous solutions. Later on we'll be talking about gases, but for now it's just aqueous solutions. So hopefully, yes, you should get your calculator. Tam, go run and get your calculator real quick. If anybody doesn't have a calculator, you should go and get one. It's better to be using your scientific calculator rather than your phone, even if your phone has an app with the scientific calculator on it, because you want to get in the habit of using the same thing you'll use for your exam. So please try to have a scientific calculator. I should get one for next time. I think Tesco's might be a bit too long for right now. But yes, calculators, please. Right, so hopefully you guys know how to use the triangles, these triangle things, I mean. So the way you use it is the thing that you're looking for, you cover that up, and because I can't cover it up on the screen, I'm just going to do an X across it. So if I was looking for volume, then I would do mass over conc. Hopefully you've all used these triangles before those, so that won't matter. You guys have already got answers and you're totally right, but we're going to go through how you do it in a second, just in case anybody is not quite as speedy as you. But well done. Well done, all of you. Real quick though, can somebody tell me what the units are for each of these? What are the units and what are the symbols? So units for mass and symbol for mass, units for volume and symbol for volume, units for concentration and symbol. Because these are the things that lose you those like extra 1 marks that could be the difference between, you know, grades that you want. Not gonna lie, you're making this too basic. That, you know, like if you're faster than everybody else, that's really great, but making sure that you know the basics is just really important. I'm not gonna, you know, feel sorry for covering the basics. Cool. So we've got people saying dm cubed for volume, which is correct. Yes, what is the symbol for volume, people? And we've got, so somebody said kilograms. So for mass, for this formula, you want to be using grams, not kilograms. So don't use kilograms. You tend to use kilograms for sort of like things like gases and things, but for moles, you're using grams. And then we've got moles per dm cubed. Perfect. Pradeep, we do not have a schedule specifically for that far ahead yet. I will, as soon as we know, you will know. Yeah, physics and chemistry do things differently, just like chemistry and biology do things differently. It's grams for most things in chemistry. I mean, that might be why when you're looking at gases, it's sometimes in kilograms, because gases tend to be more on the physics side than the chemistry side. But yes, cool. So perfect. So I'm going to remind you that it's little m for mass, because nobody answered my what is the symbol for. Little m for mass, big V for volume, little c for concentration. Don't confuse little m and big M, because big M is molar mass, if you remember. So you guys have already worked out, or lots of you have already worked out the answer to the question. So the first thing, does it matter if it's big or small? Yes. Yes. It does matter if it's big or small, because different letters mean different things. So you have to be specific. Why am I using mass? Because that is what I'm using. You can have that, because that is what I'm using. Is there a place where you can download this for later? Yep, the presentation is in the, sorry, my words are gone. In the description. The presentation is in the description. It's the blank one, but you can fill it in. Is it not moles? Lots of people are saying, is it not moles are equal to concentration? And because you're saying that, I'm going to double check, but I don't believe so. Did I combine the so like you can use both moles and mass in our concentration formula. It's so you may have been taught one for moles, but we have both. So remember that we did, if you were here last time, we did the triangle for mass, moles, and molar mass. So that might be, you might have added them together rather than doing one individually for mass, possibly. That's what you guys are confused about. But yes. So what we're going to do now is quickly run through this question, even though lots of you guys got it already. So the first thing I'm going to do is what? What about this question means that you can't just chuck things straight into the formula, people? What is the sort of bit you have to watch out for, those of you who already did the question? Needs to be in dm cubed. Yeah, thank you, lovely people. So that is why we looked at dm cubed to cm cubed. So we've got cm cubed for our hydrochloric acid. So we're going to convert 50 cm cubed to dm cubed. And how do we do that? And Hasnyan has already told me. So not quite. We've got 25 there instead. Or you did it at the end. Okay, yeah, you could do it right now, or you could do it at the end. Either is fine. But yes, we're going to divide by 1,000. So it's 50 divided by 1,000 is equal to 0.05 dm cubed. And then all we're doing is using our lovely triangle. So we're trying to calculate the number of moles. And as we've said, as you guys have kindly reminded me, you can either put mass or moles up there. So whoopsie. So we're going to do N is equal to this. So we've got 0.05 times our 5 moles per dm cubed, which gives us 0.25 moles. Hasnayn, Hasnayan. Is that right? Is that what I'm supposed to be saying? Help me out here. Was that correct? Hello, Zara. Perfect. So lots of people have gotten that correct. So we're going to move on to some more calculations for our equations. So what we're looking at here is actual reacting masses, which is the subject of this. So we've got KCl reacting with 3 moles per cm cubed of AgNO3. So we want to calculate the volume in dm cubed of silver nitrate needed to react with 10 moles of KCl. So first of all, I want you guys to tell me if you think this is a balanced equation. Is the equation already balanced, or do we need to be doing anything to it? Anybody? So we've got some no's, we've got some yeses, no's. Yeah, it is balanced, right? Because we've got, if we count, we've got 1 and 1 potassiums, we've got 1 and 1 chlorines, we've got 1 and 1 silvers, and we've got 1 and 1 NO3s. So we're all good for balancing the equation, but please, please, please check first. I'm also going to write up our formula at the top here, just so we have it. But eventually I'm going to be asking you guys to do that for me, because I don't want to have you guys not remembering, because I'm always putting it in for you. So how many, is there a timetable for what topics you covered? So there was a timetable, Vidit, for the sort of first 4 weeks, because this was sort of our tester for the web classes. And the tester sort of ends this week, and then we will be publishing a schedule for the sort of rest of time. Cool. So what do we need if we're trying to work out the volume of silver nitrate? What do we need to sort of surmise first? Does someone help me out? What's our first step? Yeah, we do have to use dm cubed. Oh no, Katie, you can watch it later. It stays on YouTube. Just go back on the SnapRevise YouTube channel and find it. Stoichiometry, yes. So you can use moles to figure out reacting masses and volumes. Yes. Why do we need to balance the equation? That's very linked to the question I just asked. What do we need to do first? Yes. So we need to figure out exactly. Perfect. Thank you, Rafaro. We need to figure out how many moles actually reacted, right? So we've said we've got KCl reacts with 3 moles per cm cubed of AgNO3, and we are calculating the volume that solution needed to react with 10 moles of KCl, right? So if we want to know 10 moles of KCl, because we've said that it's balanced, we know that in our equation, there's sort of like an invisible 1 in front of the KCl and an invisible 1 in front of the silver nitrate. So everyone saying you have to work out the mole ratio is totally right. That's another way of pushing it. So you're trying to figure out the mole ratio between KCl and AgNO3, which means that because there's nothing in front and we've confirmed that it's balanced, they're both 1s. So if we want to react with 10 moles of KCl, how many moles of silver nitrate will we need to react with the KCl? Yes, and Libby's already said it. So yeah, so there are 10 moles of silver nitrate that will have to react. Okay, so what's our next move? Perfect, everybody that said 10. What's the next move? We know we've got 10 moles that need to react. What do we need to do? Perhaps we know we've got this formula here. Should be about 1 hour and 15 odd. Divide by concentration. We can do that. So we've got lots and lots of people putting in our formula. So yes, we do have moles. We're looking for volume, right? So if we're looking for the volume of the solution and we've got a number of moles, concentration, yes. So how do we work out the concentration of silver nitrate. We know how many moles there are, but we don't know its concentration. Anybody? Yeah, we need to change. Yeah, we do. We need to change it to dm cubed. So how do we do that? Lovely. Cool. So thank you, Zara. Thank you, George. Yes, thank you, Leah. Perfect. So we're not going to be... Yeah, cool. So we know we've got 3 moles per cm cubed, but we want per dm cubed, right? So what are we doing to get to dm cubed? And I'm going to quickly flick back to our what do we already know page. So we've got 1, so this is the sort of per dm cubed. So if I put moles per dm cubed here and moles per cm cubed here, if we're converting in this direction, we're dividing by 1,000, right? To get 1 over 1,000. Does that make sense? But if we're converting in this direction, we must be timesing by 1,000. I've had a lot of people saying divide by 1,000, right? But it can't be divided by 1,000 because we've got cm cubed and we want dm cubed. Is that making sense? Can I see some emoji feedback? Because I did have lots of divide by. Yeah? Cool. So this time we want to times by 1,000. And that gives us 3,000 moles per dm cubed. So Charlie, we're not doing cm cubed to dm cubed. We're doing per cm cubed to per dm cubed. So it swaps. Does that make sense? So if you remember, that's sort of why I make sure that we cover this at the very beginning. So if we're going from normal dm cubed to normal cm cubed, it is times by 1,000. And for normal cm cubed to normal dm cubed, it is divide by 1,000. But if we're doing per dm cubed, that means it's over. It means it's 1 over 1,000. So to get back to dm cubed, you have to times by 1,000. Does that make sense? Aisha, does that make sense now? Yeah, it does. It gets a bit confusing. What doesn't make sense? So I'll run through that one more time. So think of it this way. Because we have 1 essentially means 1 is equal to dm cubed, 1 over dm cubed. And this means 1, if we're ignoring that, it means 1 over cm cubed. So it means everything, hi, sorry I'm late. Hello, Logan. Which means that 1 dm cubed is equal to 1 over 1,000 cm cubed, which means to get from 1 dm cubed, apologies, to get from 1 to the power of -3, you have to divide by 1,000. And to get back, you have to times by 1,000. I don't know if that's making any more sense. I hope it is. I'm gonna skip forward again. So we've got 3,000 moles per dm cubed. What do we do next? So if we've got 10 moles of silver nitrate, so Satata says the negative means you need to do the 1 over the number you would usually divide. Yeah, we need to do moles over concentration. So in this case, our number of moles is 10 and our concentration is 3,000, which gives us 3.3 times 10 to the -3 dm cubed. What's confusing? Is it the conversions? So it might make more sense when I'm doing the next one, hopefully. Yes, thank you, Libby. So perhaps when I get to the what are you confused I thought cm cubed to dm cubed would be 1,000. So it's just that because we're not doing, if this was 3 cm cubed, so if the question was 3 cm cubed, how many dm cubed, it would be divided by 1,000. But it's not, it's 1 over cm cubed to 1 over dm cubed. So the way that you do it changes. Yeah. Okay. We're going to look at the next bit. So this time we've got tin nitrate and hydrochloric acid. How do we know if it's 1 over? You'll see it will either look like, so you'll either have a slash, it will either be moles per cm cubed with this slash here, or it will be moles cm cubed to the -3. So both mean the same thing. It means over. So if you remember so when you see that slash, that means that it's a fraction. It means that it's moles with cm cubed over the bottom. We just don't write it as a fraction. So that's how you know. Yeah, or it has a negative power. So you don't have to write it like that. You can write it with the negative power. Yes, perfect, Aisha. Thank you. Okay, moving on. So we have 0.35 moles of tin nitrate that's reacting with 100 cm cubed of HCl. So this time we want the concentration, not the volume. So what is our appropriate formula for concentration? Negative power means that it's a fraction. So let's say we had 100 to the power of -1. It would mean 1 over 100. So you should really go back and check out your indices stuff from GCSE, because that's really important for A-level. Yes, thank you all. So our important thing for concentration is to be able to do the moles over the volume. So far, we have another situation where we've got cm cubed and we never want cm cubed. So what should we do first? Lead nitrate. Did I keep saying tin? I did keep saying tin. Thank you, Nick. Convert, yes. So how are we going to convert 100 cm cubed to dm cubed? Divide by 1,000, yeah. Thank you, everybody. So, oops. So we're going to do 100, that says 1,000. 100 over 1,000 is equal to 0.1 dm cubed. Perfect. So this time we again have a balanced equation, but we don't have sort of a 1-to-1 mole ratio. So what does that mean about, so we've got 0.5 moles of, I keep wanting to say tin, of lead nitrate reacting with HCl. If we've got 0.35 moles, how many moles of HCl are going to be reacting? Thank you, Libby. Yes, we do have a molar ratio of 1-to-2. Yes. So we're going to, thank you, Tracy. So we're going to be timesing the number of moles of lead nitrate by 2, because there's twice as many moles of HCl, because there's a 2 here. You're all wonderful. So we're going to be doing 0.35 times 2, which is 0.7. So we know that there are 0.7 moles of HCl reacting. At this point, are we ready to use our moles over volume? Do we need to do anything else, or can we go ahead and use moles over volume to calculate the concentration of HCl? Yes. Yes. Yes, thank you. Lovely people. So we're going to be doing 0.7 because that is our moles over volume, which is 0.1, which gives us 7 moles per dm cubed. And notice that I swap between, I'm gonna keep swapping between these two versions, just sort of get you guys used to seeing both the to the power of to the -3 and the slash. Yay, we did it. We did do it. That was quick. So so far, the most important things have been to change to make sure our units are there. So that's the first thing I want you to look at, the units, then to make sure you have everything you need to answer the question using the equations that you know. There aren't economic web classes at the moment, and I don't think we have plans this year to do them. What did I mean by ×2? Because 1 mole of lead and 2 moles of HCl. So if you look at the equation, you've got nothing in front of the lead and a 2 in front of the HCl, right? So that means that when the equation is balanced, you have double the amount of HCl reacting with each single molecule of lead nitrate, which means that when you're told that there's 0.35 moles of lead nitrate reacting, you have to double the amount of moles of HCl when you're figuring out the concentration. Can I explain titrations? Titrations are not on this presentation / web class, I'm afraid, unless it's in the exam questions, which I don't think it is. Why did you times 2? So shouldn't it stay at 0.35? It is similar to titrations in a way, because titrations, you might be asked to work out the sort of like the volume or the concentration. You can apply this to titrations. I'm just not sure that I have specific titrations questions. Is this topic in triple applied science? Do you mean for GCSE? Elia? Or Alea? Elia? I'm not sure if it is. Do I have, this is, I'm not sure if the syllabus is for anything else apart from AQA, EdXL, and OCR. Have a Google. The topic is called calculating reacting masses. So I'm going to go ahead and move on if that's, but there will be a time for you guys to say if something was confusing. So we're going to be talking about what happens if we're given mass instead of moles, as we sort of looked at the beginning. So I'm going to write down first the triangle that we used in the last lesson for mass, molar mass, and number of moles. And I'm going to write again our triangle for number of moles, concentration, and volume. Okay. So we have, what would you call that? It's not a nitrate. I'm going to call it Li3N because, yes, or lithium nitrogen is probably fine. So we have lithium nitrogen reacting with ammonium nitrate, and we have 100 grams of lithium nitrogen reacting with 300 centimeters cubed, and we want to calculate the concentration in moles per dm cubed to 3 significant figures. So tell me, what did I kind of just say was the most important thing when you're looking at questions like these? What do we want to sort of do first? Yep, Hasnayan. We have lithium nitride. Thank you. Balanced, is it balanced? Yes, perfect. Is it? Someone tell me. Is this a balanced equation? Yeah, it is. This one is balanced. So what it is. Let's have a look. Let's double check that it's true. So on this side, we have 3 lithiums. And on this side, we also have 3 lithiums. On this side, we have 1 nitrogen here, 1 nitrogen here, and 1 nitrogen here. So that's 3 in total. And here we have, oh, no, we don't. We have, we've got 3 plus 3, which is 6, 7. And over here, we've got 3 plus 3 here, plus another one, which is 7 again. Here we've got 4 times 3, which is 12 hydrogens. And here we have 4 times 3, which is another 12 hydrogens. Here we have 3 times 3, which is 9 oxygens. And we also have 9 oxygens on this side because it's 3 times 3. So it's definitely balanced. Yes, Fazmina, we also have moles equals mass over molar mass, which we've got up here in this triangle. Perfect. And thank you. Cool. So that was going to be the next thing I said. What do we want to make sure we do? We want to convert centimeters cubed into decimeters cubed. So I'm going to do this off on the side over here. So Tracy has rightly said, because over here we've got our reaction in centimeters cubed, and we want to change it as quickly as we can to make sure we don't carry across any mistakes. So we know we've got 0.3 conversion is critical. It is, Hasnayan, and I hope that I'm pronouncing that right now. So yes, so we know what our volume of ammonium nitrate is. So the first thing I'm going to do is tell you guys to open up a periodic table, because we're going to need molar masses. So the periodic table that I recommend is a website called ptable.com, but you can use, if you've got a textbook with you, you can use that. But please have a periodic table with you, because I want you to practice finding these things. So even if like I already tell you how many, how much mass lithium has in 1 mole, I still want you to have had a look, because it will be faster in your exam if you're used to looking for these things. Thank you, SnapRevise colleague, for putting in that link for me. So Night Hardcore says the molar mass for lithium nitrate is 34.7. I'm actually going to round up for these. I'm just going to use whole numbers, but you guys are right. So I'm going to write in the molar mass for lithium is 7 grams, and for nitrogen is 14, which means that the molar mass for lithium nitride, and whoever reminded me that it was nitride is fabulous, is, I'm going to call it 35. So we just did 23 because lithium, there's 3 of them. So 7 times 3 plus 14 is 35. So that's in grams. Is there a specific reason that you check the AQA? No, I mean, like I check OCR, Edexcel, and AQA. Did it every time, always at the beginning of the presentation. We've got the spec list for all of them. I'm sure in A-levels you can't round up. So in your A-levels, what you always do is use the number of decimal places that are in the periodic table they give you on your data sheet. So you don't round up for those. I just happen to be using a periodic table with rounded up values. Always use the values in the data sheet. So if that's 2, then you use 2 decimal places. If it's 1, then use 1 decimal place, however many. Bye, Shalon. Cool. So Libby is saying we're doing 100 divided by 35, which is completely right, because right now we're trying to find the number of moles, and we've got mass divided by molar mass, and the mass is 100 grams, and the molar mass is 35, which gives us 2.857. Why is it in grams? Why is what in grams? No, we are not going to do mass spec today. So we've got 2.857 moles. Okay, so what do we talk about at the very beginning that is important now? So we talked about, well, I'm afraid we can't do that today. We can't do mass spec today. So we talked about the ratios, the molar ratios between the different reactants. What do we need to do with this number? Yeah, thank you, Libby. So the molar ratio is 3. So we have, for every 1 mole of lithium nitride, we have 3 moles of ammonium nitrate. So we have to times our number of moles by 3 if we're going to work out the concentration of ammonium nitrate. So, oops. So we've got 2.857 times 3. And then I'm going to divide this by something because we're using our moles concentration volume. What am I going to divide by? Thank you, Andrea. Yeah, we're going to divide by 0.3. So that's why it's a good thing to have this already converted. So we're doing number of moles divided by the volume to get the concentration, which gives us 28.6 moles per dm cubed, or alternatively, per dm cubed. Cool. Next question. So this one's very similar, but instead of concentration, we're going to be working out volume, and again to 3 significant figures. So do we need to do anything to our units? Do we need to do any conversions? And Lewis, I believe you're correct. The equation is balanced. Yep, Tracy says no, no conversions. Everything's in its standard units. So we have grams and we have moles per dm cubed. Perfect. So we know the equation's balanced. We know that we have everything in the correct units. So I'm going to give you the molar masses so that I am using. So potassium is 39, molar mass fluorine is 19. And if that's the case, what is the molar mass of potassium fluoride? Okay, I will run through how it's balanced just in a sec. It's 58. Okay, so to figure out whether it's balanced, it is not balanced. Well noticed. Okay, so it is not balanced, and somebody tell me why it's not balanced. And I believe that there might be a typo in this, possibly. Because of the sodium, yeah, perfect. So you guys are wonderful. So why do I think that? So I've made a typo in my presentation. Why do I know straight away that it's a typo and it's not that the equation is unbalanced? What is similar about sodium and potassium? Anyone? So this is like a bonus question. Why do I know that the lack of balanced equation is a typo rather than the equation not being? Yes, they're both in group 1, which means that they form the same number of bonds, right? So if this is K2CO3, then this should also be Na2CO3. So my typo creates a good learning moment. Cool. So this should be sodium carbonate with a 2 there. So it is balanced. And whoever noticed that it wasn't balanced is wicked. So thank you. Who was it? I can't find it. It's going to take me too long to. How is it balanced? Thank you, Mark. Yes. Perfect. Okay. So if we have, so I'm gonna go ahead and move on. And everybody that got the question right about group 1 is fabulous. So if we've got 12 grams of potassium fluoride and the molar mass of potassium fluoride is 58, if I want to know the number of moles, what do? We're not going to times by 2 cooler. Yeah, we're going to do 12 over 58, which gives us 0.2069. And somebody's already mentioned the molar ratio, but we're not going to times by 2 because it's the potassium fluoride that's got 2, and we're looking for sodium, which should have 2 there, sodium carbonate. So because there is 1 mole of sodium carbonate to every 2 potassium fluorides, we have to divide by 2 rather than times by 2. So everybody said that is perfectly right. So I'm going to put, I'm going to keep things in 3 significant figures, but if you're using a calculator, just leave the numbers the way they are in the calculator because your answer will be more accurate. So it's 0.103 moles of our sodium carbonate. Perfect. Yes, well done, Liberty. And I keep calling you Liberty. My brain keeps smushing together Libby and Flaherty and calling you Liberty. I'm so sorry. Cool. Okay, so we've got something else that we need to do. So far, we've got the number of moles. We also have our concentration of sodium carbonate. So what do we need to do? Bye, Kula. Yeah, we need to divide by 0.8. Divide by the concentration. Perfect. Oh, that should be a 3. So 0.103 divided by 0.8 is equal to 0.129 dm cubed. And that is in our 3 significant figures. Okay, wicked. Does that all make sense? Can I see some feedback? Do I need to go over anything else? Good, we've got some yeses. How do you get that to grams? What do you mean to grams? How do I get what to grams? Davey? We did it in moles, not grams. So from dm cubed. So are you talking about how did we get from, so I don't know what you mean. How did we get from dm cubed to grams? So we were looking for the volume. So what we did is we used this, our molar mass, moles, number of moles equation to work out how many moles reacted from grams. Is that what you mean? So we have the number of grams, and because we have the concentration, we can work out, because we know the molar mass of potassium fluoride, so we worked out the molar mass from the periodic table is 58 grams, and we know that it reacted with 12 grams. So if you if you do the mass divided by the molar mass, you get the number of moles. And then once you have the number of moles, you can just use the number of moles, concentration, volume formula to work out the volume. Is that, wicked, cool. Can I start again? I can't start again, but you can rewatch it. If that, we are currently in Spanish. Can we write the answer in standard form if they didn't ask for 3 significant figures? What do you mean by standard form, Ward? So if you, 3 significant figures is pretty standard, 2 decimal places or 3 significant figures in A level, but usually they will say how many they wanted. Yeah, I'm not sure what you mean by standard form is not sort of like a length of units. Yes, there are, Andrea, there on Monday and Wednesday, but I'm going to move on because I hope that we're all fine. We're going to be doing an exam question. So if we wanted the concentration in grams per dm cubed, you don't really work in grams per dm cubed. That's not very useful because grams per dm cubed is not sort of complicated to work out, right? Because if you're doing an experiment, you know what the volume is because you've just measured it and you just chuck in the number of grams. It's not necessarily that useful for calculations. We don't know about physics yet, but we will be starting those soon. Okay, I'm going to move on to this exam question. So a student was given 200 centimeters cubed of solution X in which sodium hydroxide, NaOH, and sodium hydrogen carbonate, NaHCO3, had both been dissolved. The student carried out 2 different titrations on samples solution X using 0.1 moles per dm cubed sulfuric acid. In the first, so this is a titration question, whoever wanted to do a titration. Is this the last bit? No, it is not the last bit. In the first titration, both, although I think that because we're going to run over time, possibly I will skip the ideal gas equation part and we'll do it another time because we are running out of time. So possibly this will be the last bit, Aisha. So in the first titration, both NaOH and Na and sodium hydrogen carbonate were neutralized. In the second titration, a new sodium hydroxide was neutralized. The students' result for the titrations for 25 centimeters cubed of solution X are shown. Not going to read that bit for you. Calculate the amount in moles of sulfuric acid used to neutralize only the sodium hydroxide in 25 centimeters cubed of solution X. Okay, so what, given that we have moles and we're looking for, and we've been given a volume, what sort of equation are we going to be using? Yeah. Yes. Thank you, Libby. So we're gonna, Aisha, can you save that question for the end? Because I have to sort of think about what you're saying. So save it for the end for me. Yeah, we're going to be using the number of moles equals concentration times volume. Yes. So what is our volume? Do we know? Or what is? Yeah. So we're going to need cm cubed in. Yeah, we're right. So it's not. So I want you guys to be careful and think about what the question is asking for. So we're trying to figure out the amount of sulfuric acid used to neutralize sodium hydroxide. And the sodium hydroxide is the 25 centimeters cubed. That's the volume of sodium hydroxide. What volume of sulfuric acid was used to neutralize that amount of sodium hydroxide? Yes, Malia. It's 18. So this is why it's really important to read the question properly and not just to sort of like skim, especially in these kinds of questions. So it's actually 18. So that's the volume that we're looking at. And you're right, we do still need to be, because this is still in centimeters cubed, we need to be dividing by 1,000. Cool. So when we've divided that by 1,000, what is the concentration we're looking at? So remember, we're still thinking about sulfuric acid. How can we figure out the concentration? Does it say it anywhere? Yeah, perfect. 0.1, it says it right here. So we've had to sort of look around the question. So in the table, we got a volume from there and we got a concentration from there. So that's going to be times 0.1. And the answer would be, I'll let you guys shove that in your calculators. Yeah. I think I understand your question about whether you can do it in standard form. So when you're in standard form, you're still going to be using the same number of significant figures. That's why sort of when it says standard form instead of decimal places, it's easier to put it. Sorry, that's why it says when it says significant figures, it's easier to use standard form than it is when it says decimal places, but only by a little bit. But yes, so 1.8 times 10 to the minus 3 is the correct answer. Why did I divide by 1,000, Claudia? It's because we're in, oops. It's because our volume is in centimeters cubed and our concentration is in decimeters cubed. So you have to convert to be able to get the number of moles. Okay. So the next question says, calculate the concentration of sodium hydroxide in solution X, and it says moles per dm cubed. So what piece of information do we already have that's going to be useful? What did we just work out? So again, we're going to be using this triangle. Yeah, someone says moles over volume, which is correct. That is what we're going to be doing. We're going to be doing the number of moles over volume at some point. That's our N over V. Yeah, so if we know that we've got 1.8 times 10 to the minus 3 of sulfuric acid, what do we need to do to that to get the number of moles of sodium hydroxide? Anyone? So this is the point where the molar ratio gets important. Anybody? Yeah. What's the equation? So the equation's over here, Aisha. Yeah, we've got some people saying times by 2. And that is correct because we've got, for every mole of sulfuric acid, we've got 2 moles of sodium hydroxide, right? So that means we have to times our number of moles of sulfuric acid by 2. So I'm going to do 1.8 times 10 to the minus 3 times 2 is equal to 3.6 times 10 to the minus 3 moles of NaOH. And you don't have to write like moles of whatever it is in your exam, but I tend to because it's easier to sort of go back and check your work if you know what all of the numbers mean. Otherwise, it just looks like a list of numbers. So I would recommend that you do that as well. Cool. So we've got 3.6 times 10 to the minus 3 moles of sodium hydroxide. So we know that we're doing moles divided by volume. So what is our volume of sodium hydroxide? Yeah. So there's 3.6 times. It does. It says 25 centimeters cubed over here, Leah. So we've got, so it is a bit of a hunt to find all of the information. So we know we've got 3.6 times 10 to the minus 3 moles of NaOH in 25 centimeters cubed. So what we're trying to do is work out how many we have. Yeah. Yes, so we're doing 25 divided by 1,000, which Aisha and oh, hello, Fatima. I haven't seen you. Did you only just turn up? Yes, so we're doing 25 divided by 1,000 is equal to 0.025. And then what's the plan? What do we do then? So now we have our volume in dm cubed. We have our number of moles. How do we work out the concentration? Yeah, moles divided by volume. So our moles, 3.6 times 10 to the minus 3, divided by the volume, which is 0.025, which is equal to 0.144. So that is our concentration. Yes, well done, Leah. Hi, Fatima. Yeah, I did kind of wonder where you were because you're sort of my most common commenter. No worries, don't worry about it. Cool, so calculate, the next question is calculate the amount in moles of sodium hydrogen carbonate in 200 cm cubed of solution. Okay, so far we've been doing everything with sodium hydroxide rather than sodium hydrogen carbonate, which has been nice because we've actually been given a volume for sodium hydroxide, right? Whereas we've only been given a volume for both sodium hydroxide and sodium carbonate. So what do we need to do to figure out the volume of sulfuric acid to neutralize just sodium hydrogen carbonate? It's more obvious than you would think. Yeah, so it's not quite. We've got some good ideas. Aisha, you're closest, but you're not quite there. Any other ideas? We've got some. Yes, we finally, Hannah, yeah, you're right. So if it takes 29.5 centimeters cubed of sulfuric acid to neutralize both sodium hydroxide and sodium hydrogen carbonate, and it only takes 18 to neutralize just sodium hydroxide. To figure out the volume that we would need to neutralize just sodium hydrogen carbonate, God, these are all a mouthful. We have to take them away. So I'm going to take them away and convert them at the same time because there's not much space in here. So what am I converting them to and how do I do it? Yeah, we've got lots of people got the right answer already, but how did you guys, so both Leah and Leah. Sorry, I thought it was two different people. Leah, how did you get from, yes, yeah, we divided by 1,000. So I'm going to take them away and divide them by 1,000 all in one step to save some space. And as you guys all said, so it was 11.5 and then we divided by 1,000. So now we've got 0.0115 dm cubed. So just minus and convert to dm cubed. Yes, Millie, exactly. Cool. So what's next? So we're trying to figure out the number of moles, remember? And we've been given a volume. And now we know how much sulfuric acid it took to neutralize sodium carbonate. So what did we do? Remember here, we sort of had a very similar question, right? We had an amount of sulfuric acid and we wanted to know the volume of the sodium hydroxide. So what's similar about these two questions? How can we use our knowledge from there or from the rest of the information? What do we need to do next? Somebody help me out. We could do molar ratio right now, but I was going to do something else first. Something to do with our formula. Yeah. So right now we have a volume. So remember, we're trying to work out the number of moles. So that's our concentration times our volume. We have a volume here, and this is our volume of sodium hydrogen carbonate. What do we want to times it by? Hello, George. Anyone? Okay, so I'll put it differently. So we know that it's been neutralized by 0.1 mole per dm cubed concentration sulfuric acid, right? So this is what we used in this question. We times our 18 over 1,000 by, yeah, so we know the concentration of the acid and we also know the molar ratio. That's something you guys were all saying. So we know the concentration of the acid and the molar ratio. If we know the concentration of the acid is 0.1, how can we work out the concentration of the sodium hydrogen carbonate? What are we going to be doing? Yeah, we're going to times by 2. Times them together. Yeah. Cool. So what I'm going to do is I'm going to times this by 0.1. I'm also going to times this by 2, which is going to give us 0.0023. So at this point, we still have more to do, right? Because this is the value for 25 centimeters cubed, not for 200 centimeters cubed like we want, right? So what are we going to do? How do we get from 25 centimeters cubed to 200? Yes, we need to, why did I times by 0.1? Because our sulfuric acid is at a concentration of 0.1 when it neutralizes it in the question. So because we've got 0.1 moles per dm cubed of sulfuric acid at a molar ratio of 1 to 2, we times it by 0.1, which is the concentration from the concentration times volume equation, and we times it by 2 to take into account the molar ratio, which gets us 0.0023 in 25 cm cubed. And you're all right, we need to times by 8 to get from 25 cm cubed. So the 8 comes from the fact that we're looking for 200 centimeters cubed, but we're working with values from 25 centimeters cubed. So to work out how much we need in moles for 200 centimeters cubed, we do 200 divided by 25 from here, which gives us 8. So we're going to times 0.0023 by 8, which gives us 0.0184 moles of sodium hydrogen carbonate. And I hope that all made sense. So I think it might actually be worth trying to do more calculating reacting masses at some other point, because I think it's quite a tricky topic. But for now, I don't get why we divided it by 25, because we have, oh, sorry, I just put the pen in the little pen slot. So because we have we're looking for the number of moles in 200 cm cubed, and we were using our number of moles, the concentration from this information here. And this information is all about if we neutralize with 25 cm cubed of sulfuric acid. So instead, so we're essentially asking, what do you need to times 25 centimeters cubed in volume by to get to 200 centimeters cubed in volume, because that will also be how much you times the number of moles. Could you, so the question that I just did, Lewis, does that make sense, Malia? Yeah, so I'll run through this question one more time before I go, because this is I'm going to skip ideal gases, guys, and just run through this question just one more time, and hopefully it will make more sense. Okay, so we're trying to calculate the number of moles of sodium hydrogen carbonate in 200 centimeters cubed of solution X. So the information that we have is that the volume of sulfuric acid needed to neutralize both sodium hydroxide and sodium hydrogen carbonate, and we have the volume of sulfuric acid needed to neutralize only sodium hydroxide. But we want to know sodium hydrogen carbonate, right? So the first thing that we do is work out the volume of sulfuric acid needed to neutralize only sodium hydrogen carbonate. And we do that by taking away the number of the volume needed to neutralize both from just sodium hydroxide. So we do 29.5 divided by 18, which gives us some number, and then we divide, whoops, my gosh, where did my annotations go? There we go. Then we divide by 1,000, because that's in cm cubed. Why am I using 18 and not 25? Because 25 is the volume of sodium hydroxide, rather than the volume. Calculate the number of moles. So this was, the 25 is for the question about sodium hydroxide rather than the question about sodium hydrogen carbonate. So this is just specifically a question asking how many moles of hydrochloric acid you need to neutralize 25 cm cubed. It's not necessarily important to the setup of the question. So does that make sense, Aisha? I'm going to move on. Tell me if it doesn't make sense. Yeah, cool. So I divide by 1,000 because that means that we're in dm cubed rather than cm cubed, which gives us 0.0115 dm cubed. Okay, so this is 0.0115 dm cubed volume of sulfuric acid needed to neutralize sodium hydrogen carbonate, right? So we've got a volume of sulfuric acid. We're not in sodium hydrogen carbonate moles yet. So if we want to work out the number of moles in the solution of sulfuric acid, not of sodium hydrogen carbonate, we have to times by the concentration. So right now we have a volume for the amount of sulfuric acid needed to neutralize sodium hydrogen carbonate. We have a concentration. So this is the volume of sulfuric acid needed to neutralize only sodium hydrogen carbonate. I'm hoping that makes sense. So we're talking about sulfuric acid right now because it's the only information we have. So to work out the number of moles of sulfuric acid that neutralizes sodium hydrogen carbonate, we times by its concentration, and its concentration is up here. It's 0.1. So we times by 0.1, which gives us 0.00115. So this is the number of moles of sulfuric acid needed to neutralize 25 cm cubed of sodium hydrogen carbonate. Sodium hydrogen carbonate is the thing we're trying to work out the moles of, however. So instead of using this number, we need to times it by 2. And that's because for every 1 mole, I'm going to delete all of this so there's more space. For every 1 mole of sulfuric acid, we have 2 moles of sodium hydrogen carbonate. So now, instead of having the number of moles of sulfuric acid, we will have our number of moles of sodium hydrogen carbonate. So that gives us 0.0023 moles of NaHCO3, but that is for 25 centimeters cubed, as it says here as well. So these are all values for 25 centimeters cubed. We do not want 25 centimeters cubed. We want 200 centimeters cubed. Bye. I was saying bye to Haroon. Oh, right, that's Nick. I'm not Sir. I could be a Sir. Cool. So we need to times this number by something that will make it for 200 cm cubed, right? So to work out what that number is, we're going to do 200 divided by 25, which is 8. So we're going to do 0.0023 times 8, which is the same as 0.0184. Does that make sense? Yay, I'm glad, Malia. My brain's a bit fluffy because I've been a bit unwell, so I was worried. I was a bit worried about the session, but I'm glad it's helping. No, it's okay. I'm as happy as a sir as I am a miss. Good. Okay, cool. So it should make sense, and that means that I think we're at the any questions bit, because I'm going to skip all of the ideal gas because we literally just have run out of time. So what we should be able to do now is not this bit, but we should be able to perform calculations with moles, concentration, and volume. Yay, Malia! I'm glad. And AXA. So they are weekly, but this was sort of our test run, which I'm gonna get to. So this is all our test run for SnapRevise 2.0, which is like our sort of new version of our website, and we're really excited about it because ideal gas, not necessarily straight away, because possibly there's going to be a bit of a break, because this was our sort of 4-week test run of doing these web classes, and it's all to see how it will work for our SnapRevise 2.0, which is coming out on October the 16th. So it will be part of the ultimate package, which will be paid for, but we know that some people won't be able to afford it. So we will do some web classes for free. So don't worry about it if you can't afford it, but if you can, then, sign up and you will see more web classes. If you've already, so the question was from Fatima, so ideal gas is next. We will figure out the schedule, and I'll make sure I go back and cover everything that we've had to skip. So these are all sort of like teething problems with like the length of the web classes because they're new, and now we know how long everything takes. We're going to be able to figure out how to schedule it a little bit better. So I really appreciate everybody sort of bearing with us for the timing for these first few ones. So thank you, lovely people. This is not the last free one. There will be more free ones. I'm just unsure of the schedule at present because we're sort of launching our new thing. Your coupon code is coming. In fact, I will show you it now. There you go. It's RM40. So this is the coupon code for the SnapRevise that exists now. You will automatically be upgraded to the basic package of the new one on October the 16th. And then if you want to upgrade further, then you can. So Aisha said, question from earlier on, if physics comes out on October 16th, is there a way of keeping them free like bio and chem? That is so just not my decision. I don't know. It's not my decision because I'm head of chemistry, not head of physics or the pricing. I just teach and make the content and answer your questions and things like that. I will still be here. I will still be here doing some free sessions. I will still be here probably once a week doing free things. So don't worry about it. I'm still going to be here. I do not, Leah. Drop us an email. Pop onto our website, and I'm pretty sure there's like an email contact form to ask about psychology. I mean, like, I can ask, but I'm not sure it will make any difference, Aisha. That kind of decision making is not mine, and I don't think it's a suggestion. You write in a really strong argument for it. I don't. Yes, but then just guys, keep in mind that these do cost money to make. We have to research everything, make all of the presentations. I have to be here giving you the web classes, so it's not free to make. So some of them have to be paid for, though we really do want it to be accessible to as many people as is humanly possible. So we will still have free ones, but it has to be paid for in some way, right? You have to come up with the argument yourself, Aisha. I can't come up with it for you. What other topics will I be covering? I will be covering the whole syllabus. There will be like the entire chemistry A-level syllabus covered this year, for both year 12 and 13. Is the payment for year 12 and 13? Yes, it is, but remember that it's for the basic version. So the basic version, have a look at the packages list, does not include the web class or the drop-in tutors. It includes revision guides and exam walkthroughs and videos on all of the topics, but they are really good. Do we have any other questions? And nobody acknowledged the majesty of my pineapple last time, which I was really sad about because I really like this questioning pineapple. Can we see the price? I do not have the pricing. The pricing will be released very, very soon. How often will the free one be? I believe it will be once a week. It may not be once a week straight away. We have to test things out, but I believe it'll be once a week. Yay! Thank you, Livy, for liking the pineapple and for being happy with the class. I'm glad. I'm sorry that I kept calling you Liberty because my brain just can't not merge your name together. But if you ever need a nickname, you can have Liberty, and say that a random chemistry teacher online came up with it for you. Can I go back a second? Yes. Go back a second to what? I'm glad you think it's a cool nickname. Previous slide. To this one or to the package slide? Code slide or package slide? See you next week. Malia, we will have free classes throughout the year. So we've got like a year of free classes. Got it. Okay, cool. You're welcome. If there are no other questions, I'm gonna head off and have some dinner and things. Yay, I'm glad it was helpful. Bye. Oh, thank you, Zara. But again, compliment me on my brain. My brain is the cool thing, right? I'm glad I helped with conversation. Bye, Zach. You have a good evening too, Haroon. Okay, I'm gonna go. I'm gonna turn off my brain is rather large and I have a really big head also. So I think that's either true or there's just like a lot of space in there because hats never fit on my head. Bye, Fatima. Have a lovely evening. I hope to see some of you guys on Thursday, which is the A2 one. So if any of you are revising for year 12 and you're in year 13, come on Thursday. Goodbye, lovely people. I'm gonna